Okay, so we're going to talk about how we add and subtract. We're going to go over AA13, which is add, subtract, multiply monomials and polynomials, but we're going to focus mostly on the add and subtract today, and tomorrow we're going to talk about multiplying. So our learning objective is how do we add and subtract algebraic expressions. Here's the vocabulary that we're going to cover in the next few pages. Monomial, binomial, trinomial. These are all a type of polynomial. We're going to define what simplest form means, ascending and descending order. Okay. So one thing that we should understand is, first of all, that expressions are unlike equations because expressions have no equal sign. Okay, so another name for expression is called a polynomial. And the rules that are involved with expressions, just in general, and I'll keep reminding you of this. So with expressions, there's only a few things you can do. You can add 0. So with expressions, let's just write this. With expressions, there's only really a couple things you can do. You are asked to simplify. Okay, you could be asked to distribute, which is part of the simplification process. But you cannot solve expressions. Okay, that is a word that we use with equations. You cannot solve expressions. So you are asked to simplify. Distribution is part of simplification, or you could be asked to evaluate expressions. So there's two main things you can do with expressions. Okay, evaluating expressions we've done before and you've done in previous grades. That's substituting, like if I say evaluate this expression right here for x is equal to 3, you'd substitute 3 back in for x, and that would happen to be 14. So that's one thing I can do. Simplifying is the process that we're going to go over the next few days. Now, the simplification process, to simplify, there's only 2 rules. The only thing that you can do is you can combine like terms, or you can distribute, or you can add 0. So I'm going to put 0 in quotations because remember 0 means that you can add or subtract the same thing. And that's equivalent to 0. So it's like our 0 pairs, same term, and that will get you, that's a type of 0. Okay, we'll go over that more later. Or we can multiply by 1. And again, 1 is going to be in parentheses, okay? Remember, 1 can look like many things. 1 can be a over a. 1 can be, a number 3 over 3. It can be x plus b over x plus b. Those are all forms of 1. All right? Okay, now polynomials, which is the same as expressions, there's a few different types of terms with polynomials. There's a term called a monomial, which is a term it's a number or a variable or the product of number and variables. So this is a number. It could be 5. It can be the product of a number and a variable. It can be some expression with a variable over a number. Or it can be something like this, which is the product of a number and a variable. But it cannot be, this thing is not 5 over w is not an expression because w is in the denominator. And that cannot happen. Okay. A binomial is a polynomial with 2 unlike terms. So these 2 terms are unlike because that has an a and this has a b. So I can't add them together. So they end up being 2 terms. Another name for a monomial is a term. Okay, so a binomial is 2 monomials, right? So that's why that bi means 2. Oops. Bi means 2. Alright, and then we have a trinomial, which is 3 terms, 3 unlike terms. Because if they were like terms, they would reduce to either a binomial or a monomial. So these are all unlike terms. Okay, so a polynomial is in simplest form when it contains no like terms that can be added together, that are not combined. Okay, so these, and this is not the, this right here is not simplified because both this and this are like terms, so I've got to add them together. So I would get 6x plus 4x is 10x squared minus 2x minus 9. Now this right here is the simplest form of the expression, or the trinomial, because it's 3 unlike terms. The first term has an x squared, the second term has only an x, and the last term is what we call a constant. It has no variable. Oops, it has no variable in it. Okay, that's a constant. Alright, we say that the expression, the polynomial or the expression, is in descending order when the exponents of a particular variable decrease as we move from left to right. So here we're looking at the variable x, and the exponents are 4, 2. Remember, when you don't see the exponent's 1, and the constant actually has a variable raised to the 0 power, right? Because remember that x to the 0 power is just 1. So I can write 11 times x to the 0 power. That's the same as 11, because that's the same as 11 times 1, which is 11. So a constant, you can rewrite it with a variable term, but the variable term is going to be to the 0 power. We don't often write it in this form because it's not advantageous for us to do it, but just remember that you can do it if you need to. So this is descending order. So descending, like if you were walking down the stairs, you're descending the stairs. So it's reduced. You see the variable with the highest exponent first, and then all the other the exponents reduced by that highest exponent. We say a polynomial or an expression is in descending order or ascending order when it's increasing. So ascending means you are walking up the stairs. Okay, so remember this constant 22 is the same as 22 times y to the 0 power. So we can really think of this as y to the 0 power. So here the exponent is 0, then 3, then 4, then 11. So it's ascending. Okay, we typically write polynomials in descending order. That is our preference. So you won't often see it in ascending order. You might be asked to do that just as an exercise, but just typically we write it in descending order. Okay, so if you want to pause the video and see if you can do this task by yourself, you want to write the following terms in ascending order. So remember, ascending means like you're going upstairs, right? So you ascend the stairs. So you want to start at the lowest point and go to the highest point. So you want to start with the lowest. You want to start with the lowest power. Now remember, what we're going to look at is we're going to look at powers of y, because they all have y in them. Remember, the 29 can be rewritten as 29y to the 0 power. And we talked about how these two are equivalent expressions because we can essentially multiply anything by 1. Well, another name for 1 would be any variable raised to the 0 power. That's 1. So a way of multiplying something by an equivalent expression is rewriting it, with little tricks like that, right? So the smallest exponent I see is 0, so I'm going to write 29. And then I'm going to write for y. Right? Notice I don't write y to the 1 or 29y to the 0. I'm just going to sort of keep that in my head as I go through this, but I don't have to rewrite it in that form. I just wrote it here in that form so that you can see why I'm writing it first. And then this is 8y to the 3rd, then y to the 9th, and then negative 6y to the 1000th. Okay? If I were to write these in descending order, so descending meaning like going down the stairs, starting at the highest exponent and going down to the lowest, we would write, these all have x's, so we're going to focus on the variable x and the exponent on x. So we'd write 111x, we would write 1/3 x to the third, and then we'd write 111x squared, and then negative 5x to the first, and then 8x to the 0 power. Okay. Now we're going to talk about how we simplify expressions, because that's the next thing that we do. So you might want to take a second and pause the video and write down these notes. Our step one is, anytime, we've done this before with equations, when we had equations with things that we need to distribute, we're going to add a 1 in front of any parentheses when there's no number there. We're going to use KCC to change subtraction into addition. We're going to get rid of parentheses either by distribution, or if it's just addition, you can drop them. We can use the commutative property. Since we've changed everything into addition, we can use the commutative property to rewrite expressions so that the terms are near to each other, and then we're going to add like terms. Okay, so this expression happens to not have that 1 in front, so it's being this whole term, this whole quantity is supposed to be being subtracted. So the first thing I'm going to do is I'm going to add a 1 right here, and the second thing that I'm going to do is do KCC. So I have 3x squared plus negative 1 times 8x. And I'm going to keep going with my KCC here. And that's still in parentheses, and I have that plus 4 outside. And then I'm going to distribute the 1 through, so that there's 3 things I have to multiply by. 3x squared plus negative 8x plus, now negative 1 times negative x squared is just x squared, right? And negative 1 times 4 is negative 4. We have the plus 4. Okay, and you can already see right here that those are a 0 pair, so you can cancel those out. This right here and this right here is are like terms, so you don't have to move them next to each other, but you can think of, since we all have all addition, we can just think of adding those two together. So that's 4x squared plus negative 8x. And technically, it's more simplified if they have less symbols, so I'm going to change this combination of plus and negative into subtraction. So my final answer is 4x squared minus 8x. Okay, and that is how you do those. Let's try another one. So example number 2. Now this is a series of parentheses, so we got to be kind of careful here. So when we have these are called embedded parentheses. So when we have 2 parentheses, we start in and we work our way out. And we ask ourselves, well, with PEMDAS we always say do whatever's in the parentheses first, but here we can't subtract 8c squared from 4 because those are unlike terms, so I can't actually do what's inside the parentheses, so I'm going to have to look outside. Now this is just 10c plus this quantity, right? So it's 10c plus this whole quantity. Since there's addition and it's not subtraction, I can just drop those inner parentheses. So let me just drop those first. Plus 4 minus 8c squared. So if you have addition outside of parentheses, you can just drop that. Okay, if you have subtraction, it's a little trickier because it's subtracting the whole quantity, which changes all the signs inside. And again, okay, there's things I can do inside the parentheses here. I can subtract 8. No, actually, that's wrong. No, I can't subtract those two things together. Those are unlike terms. Okay, so there's nothing I can do inside the parentheses, so my next step is to just look outside of it. Now that's addition, so that says I can still continue to drop the parentheses here. So, and I'm going to use KCC right here as I go through to change addition into to change subtraction into addition, because now all my terms here are being added, and so I can think of using the commutative property to get these two terms together. Remember that's negative 1c squared plus negative 8c squared is negative 9c squared. And I want to consider writing this in descending order, right? So I want to start at the highest exponent and go down. So c the squared, the 2 on the exponent is the highest exponent, so I'm going to combine it with that. Now let me look for anything with just a c to the first power. So we have 10c to the first power, nothing combines with that, and I have a plus 4. My question is always, is this in the most simplified form? And the answer is not really, because I don't really need that 1 on the second term there. So simplified form is reducing the number of symbols you use to write equivalent expressions. and also making sure that none of the terms are like terms that you would add together. So none of those terms are like terms, so that's as simplified as it gets. Now your third example, okay, so be careful, just take a minute and look at what's going on here. This is a trinomial, and you're subtracting an entire trinomial, okay? So you have to be very careful. This is similar to when you have like a 3-digit number, like, 854, and we're subtracting 120, we'll say. Well, when every part here, we're subtracting the top from the bottom. So sometimes people like to write this in a vertical way. They like to write negative 4x squared plus 2x minus 3 minus, and they write the parentheses like this, and then they write 2x squared minus 5x minus 11. So you kind of just have to think of this as, this actually gets kind of confusing because you have to think of subtracting all of these terms in here. So I like to do it a different way. I like to keep it horizontal. And so it's this whole term right here, which I can drop the parentheses here. There's nothing I can do inside the parentheses, and there's no number on the outside here, so I don't need to distribute. So I can just drop those here. Okay, and I'm going to add a 1 in front of this, and I'm going to use KCC. So in this way, K is the entire trinomial here. The C is changing here, and actually the C is going to be on the sign of the 1 there. So what I have is plus negative 1 times the quantity 2x squared. And let me just continue using KCC here. Okay, so plus negative 5x plus negative 11. Okay, so the rule is add the 1, use KCC, and if there's any subtraction inside of the parentheses where you have to distribute through those parentheses, the first parentheses I didn't have to distribute anything in, so I can keep that minus 3. The second parentheses I'm going to have to distribute that negative 1 inside, so use KCC to get all the terms prepared to distribute. Okay, so we're going to keep that negative 4x squared plus 2x minus 3 plus negative 1 times 2x squared is negative 2x squared, plus now negative 1 times negative 5x is 5x. Those are getting sort of in the way there. So negative 1 times negative 5x is just positive 5x, and negative 1 times negative 11 is just plus 11. Okay, so in this case we do want to sort of, the best thing is to just go ahead and change everything at the onset. So I'm going to just use KCC here. So I have negative 4x squared plus 2x plus negative 3. So really I should have done that move up there, because I want to be able to use the commutative property of addition on these so that I can think of like terms as being next to each other. Okay, so let's just sort of highlight the like terms. This one right here, this one right here, and this one. Okay, now we also have, let's see here, we also have this one right here and this one, and then we have the constants. Then we have the constants, this constant and this constant. Okay, so let's go ahead and think of those as being next to each other, and we want to write them in descending powers of x because that's typically how we write them. So the first exponents I'm going to focus on are the exponents of 2. So negative 4x squared plus negative 2x squared is negative 6x squared. Okay, and 2x plus 5x is 7x. Okay, and sometimes I like to cross them out as I finish them. Okay, and negative 3x plus 11 is positive 8. All right, and there's no terms to simplify. They're all unlike terms. So that is as far as we can go with that expression. That is as simplified as it gets. Okay, and that's the end of the lesson. So go ahead and answer the quiz question that you have on Edmodo.